Good morning. I'm Maher Damak. I'm the co-founder and CEO of Infinite Cooling, which I co-founded after my PhD at MIT with Professor Kripa Varanasi, who spoke earlier this morning. And our mission is to address industrial cooling towers and make them more efficient. And the reason we're targeting this problem is that cooling towers account for over 50% of all industrial and commercial water consumption. And they are used across industries like power, data centers, manufacturing, and air conditioning. And recently, cooling has become a major bottleneck in a number of industries. So we've seen headlines about power plants having to shut down because they couldn't get enough water for cooling. We've seen similar headlines about data centers struggling to build more infrastructure in water-stressed areas. And with climate change, air conditioning is growing a lot, whether it's on the building level or district cooling. And all of these applications use very similar cooling towers that we're addressing. So very briefly, the way cooling towers work, if you're not familiar with them, is they take hot water in from a process, and then they cool it down and send cold water back to that process. And the mechanism they use is evaporation. So essentially, they evaporate some of that water vapor, and then some of that water that's coming in, and then water vapor is generated and then released. And you often see these plumes or white smoke coming out of these cooling towers, and that's essentially from that water vapor that's condensing. So what we developed at MIT and now commercialized is a technology to capture the water that's coming out from those cooling towers to be able to recycle it. So essentially, we use an electric field approach where we apply a high voltage electric field that generates a cold plasma at the exhaust of these cooling towers that charges the water droplets in the stream. And then we use an electric field to attract all of those droplets toward the collection surface. And then we capture it all and then send it back for reuse. And there are a few advantages here. First, the water is very pure. It's water that's evaporated and then recondensed. So it's essentially distilled or demineralized water. The second effect is plume abatement or elimination of that white smoke, as you can see in that picture from one of our sites, which can help comply with regulations around those emissions. So that's what we are selling on the equipment side. And then we also provide sensors and analytics also for cooling towers. So we have a suite of sensors specifically designed for these environments, plus physics-informed machine learning algorithms that can do real-time monitoring, predictive maintenance, optimization on these industrial cooling towers. And the goal there is to minimize their energy and water consumption and make them as efficient as possible to increase the process efficiency of whatever system they're cooling. So let's look at the case study here. So this is one of our customers. It's a waste-to-energy power plant in Pennsylvania in the US. So this customer contacted us because they had water scarcity issues that was impacting their reliability. So they were not certain they could get enough water to run their operations. And they didn't know how well their cooling tower was behaving. So we started by installing our TowerPulse solution, which is the analytics solution to kind of evaluate the system and find low-hanging fruits. We were able to do a number of optimizations there on their water flow controls, for example. We identified some maintenance needs that they needed to do that they followed on just after. And then we also installed our water capture system on one of their cooling towers that you can see there. And within the first year of operation, just to give you an example here, we were able to save them over 1 million gallons or 4 million liters of water and 4,000 megawatt hours of additional electricity production due to the cooling efficiency increase. And then beyond cooling towers, another application we started doing recently is also carbon capture. So actually, carbon capture systems, whether it's point source capture or liquid direct air capture systems, will use a mist of liquid to contact the air. And then there's a lot of that mist that's released as drift from these systems. That's a big problem. So we can use the same technology we're using to capture the water from cooling towers also on carbon capture applications. So these systems, are already deployed at a number of sites across the world. So these are some of our customers in various industries. So we work in power generation, all thermal power. Like we have customers in nuclear, gas, waste to energy, in various industrial applications like chemicals, like fertilizers, pharmaceuticals, etc., data centers, metals, etc. And then the final category is air conditioning or HVAC, whether it's district cooling or smaller applications. And the reason we're here today is we're looking to collaborate with Japanese companies on a number of topics. So first, if you have cooling towers, we can definitely help make them more efficient, reduce their energy and water consumption. That's a direct application. If there are regulations around the plumes or the white smoke from cooling towers, and I know those restrictions are pretty harsh in Japan, we can help address those a lot more efficiently. And then if you're developing any carbon capture systems, we can also collaborate on those to solve that emissions problem. And then beyond Japan, we're looking at a number of projects within Asia and the Middle East as well, where a lot of Japanese companies are very involved, and water scarcity there is a huge issue. So we're looking at collaborating in those on those projects, mostly in power generation, chemicals production, and chiller plants. So you have my contact information there. I'll be at lunch, and yeah, happy to discuss more. Thank you.
Thank you, Maher.